For chapter 3, we are going to do some terminology. There's going to be 2 parts to lesson 3.1. And let's just go ahead and get started. We're going to go through quite a bit of terminology, but we are going to also do several examples to help you with the terminology. So we're starting in chapter 3. It's all about probability, and it starts with experiments. An experiment is a planned operation carried out under controlled conditions. We talked a little bit about designed experiments in chapter 1. A result of an experiment is called an outcome. Now, for an outcome to happen, we have to have a sample space, which is the sample space of an experiment is a set of all possible outcomes. An event is any combination of outcomes, so multiple outcomes together. The probability of any outcome is the long-term relative frequency of that outcome. Remember relative frequency? We talked about that in chapter 1 and 2. So as we're coming up with probabilities, classical probability, we talk about things that are equally likely. It means that each outcome of an experiment occurs with equal probability. So drawing a card from a deck, not worried about the suit or the number, rolling a die, flipping a coin, those would be things that are equally likely. To calculate the probability of an event A when all outcomes in the sample space are equally likely, count the number of outcomes for event A and divide by the total number of outcomes in the sample space. For example, if you toss a fair dime, there are 2 outcomes, heads and tails. H will be heads and T will be tails. We denote the probability of getting heads as P of H, the probability of heads, equals 1 out of 2, because there's one way to get a head and there's 2 possibilities when you flip the coin. Every probability must satisfy the following statement. It must be bigger than or equal to 0 or less than or equal to 1. Okay, as we move throughout chapter 3, we are going to talk about some different situations. And when you're talking about probability, which we do in our everyday life, right? If you're playing Monopoly, if you're playing a card game, we're like, well, or euchre, what is the probability that we're going to get a jack or an ace on the next draw? So the word or means this: an outcome is in the event A or B if the outcome is in A or is in B or is in both. Okay, so or is it can be in either or both. For example, let A be the set of 1, 2, 3, 4, and 5, and B is a set of 4, 5, 6, 7, 8. A or B would be any of them in both. Notice that 4 and 5 are not listed twice. So because 4 and 5 are both in A and B, they can only be listed once. The other type of event could be and. An and event is an outcome is in the event A and B if the outcome is in both A and B at the same time. So as we move along, we're going to see that or is usually related to things that add, and is usually related to things that multiply, probabilities that multiply, and or is usually related to probabilities that add. So let's look at the example of an and. So for example, let A and B be 1, 2, 3, 4, and 5 for A, and B is 4, 5, 6, 7, 8, respectively. Then A and B is 4 and 5. They're the only ones that are in both A and B. We're also going to talk about complements. Not a compliment where you tell your friend that they look nice today. A complement of an event A is denoted as A prime. We say that. A prime consists of all outcomes that are not in A. So that means if probabilities can only be bigger than 0 and less than or equal to 1, if you are in A and you are not in A, if you add them together, they always equal 1. So A, the probability of A and the probability of its complement are always equal to 1. So let's look at an example here. S is a set of 1 through 6, and let A equal the set of 1 through 4. then the complement of A would be 5 and 6. They're not in A. The probability of A is 4 out of 6. So A is a subset of S. The probability of A prime is 2 out of the 6. A is 1 through 4, and A prime is 5 and 6. The probability of A plus the probability of A prime is 4, 6 plus 2, 6 equals 1. The conditional probability of A given B is written as. So we're going to also talk about, you might hear somebody say, what is the likelihood of driving off the road in slippery conditions in the snow? And there is some probability. And then it's what is the likelihood of getting in an accident in the snow, a car accident. So that's kind of a conditional probability. You have to actually slide off the road before you can actually get into the accident of going into the ditch. So we're going to talk about conditional probability. It's written as this: the probability of A given that B has already happened. Okay. A conditional reduces the sample space. We calculate the probability of A from the reduced sample space B. The formula to calculate the probability of A given B is the probability that A and B happen over the probability of B, where the probability of B is greater than 0. Let's look at an example. Suppose we toss one fair 6-sided die. The sample space is 1 through 6, but A equal a face is 2 or 3. And B is the face is even 2, 4, 6. Okay, A is the die is 2 or 3, and B is it's just an even 2, 4, 6. To calculate the probability of A given B, we count the number of outcomes 2 or 3 in the sample space B. So given that B already happened, the 2, 4, 6, what is the probability of getting A, a 2 or 3? Well, only 1 in 3. Because if B already happened, the only way that any of A could happen is the 2. So we're going to show you in formula. So we get the same result by using the formula. Remember that S has 6 outcomes. So the probability of A given B is the probability of A and B. So the probability of A and B is the number of outcomes that are 2 or 3 and even in S. That's just 2. There's only 1. So 1 out of the 6 right here. Divided by the probability of B. The probability of B is the number of outcomes that are even in S, which would be 3 out of 6. So remember that when you divide a fraction, 1/6 is multiplied by the reciprocal of the bottom fraction. So the 6's cancel and you end up with 1/3. So those are all of the definitions that we're going to work with in chapter 3. And we're going to use some of those definitions throughout the whole semester. But this is the end of part 1 for chapter 3.1, and catch me back for the second part.